So today I'll be talking to you about my environmental capstone project. I've been looking into the scientific and the political aspects of karst so that I can take this information and present it to the Forest Practices Board and eventually start my own NGO, but that'll take some time. Before I begin, I would like to respectfully acknowledge that we're gathered here today on the Musqueam, Squamish, and Tsleil-Waututh First Nations. So what is karst? Usually it's described as a type of rock that is soluble in acidic conditions, but there's so much more to the story. It's a dynamic ecosystem that is created when limestone is dissolved by the action of slightly acidic rainwater. And so you get these surface components where you have old growth trees growing on the epikarst, and you have 134, for example, in White Ridge Park, you have 134 different flora species growing on directly on the karst substrate. And then within the subsurface, you have these cave systems, and you have karst aquifers where the water flows from the surface into the subsurface, and then it eventually re-emerges at a spring, at a karst spring. And then this water drains into, for example, a fish-bearing stream, such as is in the Walbran Valley, or into a drinking watershed, such as Lacey Lake in Port Alberni. So examples of karst features are karst caves, which are formed from the dissolution of limestone and then the drop in the water table. You have karst springs, and this is in Port Alberni, where people are getting their drinking water directly from the karst spring. You get disappearing streams, where the water literally disappears into the subsurface. Sinkholes, cairn, which is a surface feature known as limestone pavement, and then you get beautiful cave formations. So this is a map showing the distribution of soluble bedrock that has the potential to form karst throughout BC. So there about 12% of the bedrock has the potential to form karst, and then in Vancouver Island it's about 4%, and most of which is karstified due to various hydrological and geological factors. So this semester I was interested in learning about the interplay between geochemistry, biology, and hydrology, and to find out if karst is being effectively managed in BC. And if you're interested in talking to me about this later, feel free to contact me. And one of the big things that I wanted to learn is, how does karst influence temperate rainforest productivity? And so what I found was that because you get excellent drainage with the roots infiltrating through the epikarst, which is the upper weathered boundary of a karst system, and you get this excellent nutrient recycling, and this enhances growth. And in studies in BC and studies in Alaska, they've found that when you compare these coastal karst forests on the karst in comparison to non-karst forests, they're way more productive, but they're also way more vulnerable. So in a quantitative study that was conducted in 1993 by Ford and Harding, they found that when you log on the karst, it's more adversely affected versus volcanic rock, displaying considerable losses of soil, moss, and litter, especially where cutting was followed by deliberate burning. Erosion was most extreme on the steeper slopes, many of which are left quite barren. Recovery is slow, even at a physiographically advantageous site. Only 20% of the original volume of timber has grown after 75 years. And so that's why I think it's really important to promote karst and to talk about this, and to make sure that forest practices are taking the karst into account so that we have these productive forests for future generations. So this brings me to the Walbran Valley. I've done some work for Sierra Club BC and the Wilderness Committee looking at the karst, and this semester I had an opportunity to go do some water sampling, comparing some of the cut blocks that are karstified to non-karstified cut blocks to see the differences in pH, conductivity, and other different parameters. So here's an example of a karst outcrop, and that's in cut block 4403. That was in the Limestone Canyon. It's a karst cave. And then that's just some old growth just growing directly on the limestone. And it's just, I think it's just incredible. And so I tested the electrical conductivity, and so if it was above 50, then I knew that it was likely influenced by karst, and then tested the pH, and I'm using a student's t-test to determine statistical significance. So far the data has suggested that karst influences the pH of stream systems, so you get more, the water is more alkaline due to the neutralization reaction between calcium carbonate and slightly acidic rainwater. And so this has important implications for fisheries productivity. So fish tend to prefer water that is slightly alkaline, and aquatic systems that are slightly alkaline tend to be more biologically productive. And also karst groundwater that feeds into these surface systems is a constant cool temperature, which is also important for cold water fish. And so I think that in BC we should do more research like they are doing in Alaska to look at these benefits, especially with the impacts of climate change and increasing water temperature, surface water temperature. So I'd just like to thank the Faculty of Environment for letting me conduct this type of experiment and to go out and into the Walbran Valley and to do this research. And the Geography Resources Department, BJ, I see you up there, for letting me use the equipment, and all the people that have helped me along the way on this adventure. Thank you very much.